Right, this question, random variable x has a normal distribution, mean of 20, standard deviation of 4. Let's make a note of that. X follows a normal distribution, mean of 20, standard deviation of 4, so 4 squared. And part A asks us to find the probability that x is greater than 25. So let's draw out our bell curve for this question with a mean at 20, and we want to find the probability x is greater than 25. So 25 is obviously on this side, so we'll draw a mark there, and we want the greater than 25, so we want this area in there, and that we'll call P. First thing you do in any normal distribution question is find the z values, so I'm going to convert those to z. By definition the mean becomes 0, and this 25 becomes, well, I can't look it up in the table because the table relates z values to probabilities and we have neither, so I've got to calculate it using the formula. The formula for the z value is z equals x minus mu over sigma. So in this case x is 25, mu is 20, and sigma is 4. So it's 25 minus 20 over 4, and that gives us 1.25. So I write that down there, and so I need to find my table to look up the value 1.25. If I get my table and look up 1.25, it gives me the probability of 0.8944. If I look at my diagram, that's clearly less than a half, and in fact the table has given us the probability of less than 25, so we have to do one takeaway. So probability of z being greater than 1.25, which is the same as greater than 25 of the actual value of x, it equals 1 take away our looked up value 0.8944, and that comes to 0.1056. Part B of the question says find the value of d such that probability of x is between 20 and d is 0.4641. And remember, we've still got the same distribution where x follows a normal distribution of 20 and standard deviation 4. Let's draw our bell curve to represent this new question. So that's 20, and what we're looking for is between x is 20 and d. D must be bigger, if that's an inequality, so d is there. And that region there is represented, I can shade it, and that region there is 0.4641. We have a probability, but we can't look up this probability. The probability we look up is all the way from 0 all the way up until here. Let's just convert these to our z values then. So this becomes 0, and this, after looking up the probability, we must actually look up 0.9641, because this area here is 0.5. So if we look up that in our table, 0.9641 gives us an answer of 1.8 for z. So 1.8. Now if I know that z is 1.8, I can use the formula now to find out what d is. So the formula we use is z equals x minus mu over sigma, and in this case z is 1.8, x is our d, that's minus 20 over 4 standard deviation, and we can rearrange that to get d, so d is going to be 4 times 1.8 plus 20, and that comes to 27.2. Right, this question says a packing plant fills bags with cement. The weight X of the bag of cement can be modeled by a normal distribution. So X follows a normal distribution. And it says the mean is 50 and standard deviation is 2. And it wants us to find the probability of X being greater than 53. So if I draw my bell curve, that's 50. 53 is clearly on this side, and we want greater than 53, so that's the area we want. And that probability is going to be P. Convert to Z values, this becomes 0, and this one I need to calculate. Haven't got a probability to look up in the table, so calculate it using the formula. Z equals X minus mu over sigma. X is 53, take away the mean of 50 divided by, this time sigma is 2, and that comes to 1.5. So our value of Z that we have is 1.5, and we should be able to look that up in the table. That's 1.5 right at the top of our table, and the probability it's greater than 1.5, in fact it's 0.9332, but this table doesn't give greater than, it gives less than. So our answer is clearly not 0.9332, it's got to be 1 take away that value, so it's 1 take away 0.9332, and that comes to 0.0668. Part B of the question says find the weight that is exceeded by 99% of the bags. We've got the same distribution here, so X follows a normal distribution, and the mean was 50 and the standard deviation was 2. Drawing our bell curve, 50 there, and it says find the weight exceeded by 99% of the bags. 99% is most of this, but it's exceeded, which means greater than, so effectively we're going to have a value here. It says weight, so I'm going to call it W, and this value, these are all the values which exceed W, and that is going to be 0.99. Now that value is not actually going to appear in any tables. What I'm going to look up is this value here. That's the probability I'm going to use as 0.01. So if I change them to Z values, this becomes 0, and this becomes what I can look up in the table 0.01. That's a nice rounded figure, so I'm going to use the second table. 0.01 is here, so we've got a value of 2.3263. So I'll write that down as my Z value, 2.3263. Clearly that's not our value of Z because it's on the left hand side of 0, so it's actually minus 2.3263. Now that's the value I'm going to use in my equation so I can find W. And the standard equation, use again, so it's going to be Z equals X minus mu over sigma. This time we know our value of Z, so it's minus 2.3263 equals X, we're calling it W, minus the mean divided by the standard deviation. I can rearrange that, and if I rearrange it I get W equals 50, take away 2 times 2.3263, and that comes to 45.3474, and our unit is kilograms. Part C of this question says 3 bags are selected at random. Find the probability that 2 weigh more than 53 and 1 weighs less than 53. So effectively we want to work out a probability. This is standard probability now, and we want to go and have more than, for one bag, more than for the second bag and less than for the third bag. We've already worked out the probability of more than 53 in part A, so that's going to be 0.0668, and we've got another bag more than, so we can square that value and we multiply it by the probability that it was less than. Well, if more than was 0.0668, then less than is going to be 1 take away that value, which is going to be 0.9332. So if I multiply those together, I get the probability the 3 bags selected are more than, and less than, in that order, comes to 0.00416, etc. However, it could be that the probability the bag could be more than, less than, and more than. That would still give me 2 more and 1 less, and that equals the same. It could be probability, it could be the first one is less than and the next 2 are more than, and that will be exactly the same. So effectively we need 3 times this value here, and that will come to 0.01249. This question says strips of metal are cut to a length L, where L follows a normal distribution mu, unknown mean, and standard deviation of 0.5. Given that 2.5% of cut length exceed 50.98, show that mu equals 50. So let's have a look at our bell curve. We've got a mean here that we don't know. But Kia says, given that 2.5%, that's a very small, much less than half of the cuts exceed 50, so it's exceed, so it's coming from this way, a very small amount. Yeah, 2.5%, so that's the one, and that must be 50.98. And the region that we're actually told is that region there. So that region there was 0.025. Now it wants to show that mu is 50, so that's effectively finding mu. I'm going to standardize. So if I standardize, this becomes 0 to find our z value, and this one here, I've got the probability. It's a nice rounded probability. I can look that up in the second table, I hope. 0.025, so we've got a probability, sorry, that's the probability. This is our z value of 1.96. So this value here is 1.96, and that's the value we can use in the formula. So the formula is z equals x minus mu over sigma. Z we know is 1.96 equals x, which is 50.98. Take away mu, which we don't know, divided by sigma, which is 0.5. I can rearrange that to get mu equals 50.98, take away 1.96 times 0.5, and all of that, if you press the buttons on the calculator, does actually come to 50, as mentioned in the question. Part B of this question says find the probability that L lies between 49.25 and 50.75. Remember, we still got L follows a normal distribution. This time we know that the mean is 50 and the standard deviation is still 0.5. So let's draw our bell curve to represent that. This is 50, and our question says wants to find L between these two boundaries. So 49.25 is on this side and 50.75 is on this side, and we want between. So the area we're actually looking for is, I'm going to shade them different ways because notice this is 0.75 above the mean, this is 0.75 below the mean. So those two areas are identical. Z values, so this becomes 0, and this one here, well, I need to use my formula. So my formula is going to be Z equals x minus mu over sigma, and this time x is 50.75. Take away the mean of 50 divided by the standard deviation of 0.5 and press the buttons on the calculator, you get 1.5. So this value is 1.5. And that we can use to find the probability, but notice on this one is minus. Yeah, it's the same distance then, 0.75 above, 0.75 below, symmetrical region, so that's minus 1.5. So now we can look up this value in the table. It is 0.9332. So that means the probability of Z being less than 1.5 is equal to 0.9332. Now if we go and sort of look at our diagram and we can work out various regions, we can work out this region next, that region in there, which is Z 0 to 1.5. So the probability of Z being between 0 and 1.5 is going to be that whole region, take away 0.5, which is going to equal 0.4332. So effectively, if this whole region here was 0.9332, we know this bit's 0.5, so this region round there, that region is 0.4332. And since this region here is exactly the same as the region on the other side because they're symmetrical, we know that the probability between minus 0.5 Z and 1.5 is going to equal 2 times that 0.4332, and that's going to equal 0.8664. The last part of this question says those strips with length either less than the 49.25 or greater than 50.75 cannot be used. 2 strips of metal are selected at random. Find the probability that both strips cannot be used. Well, this is the range we calculated in the previous question. So that was a probability that they were in there is 0.8664 we found out. So the probability I'm going to put in range equals 0.8664. The probability of not in range equals 1 take away that, which must equal 0.1336. So the probability that one of them is not within the range is 0.1336, but it says 2 strips of metal are selected at random, so we actually want the probability of the first one not being in range and the second one not being in range. So that equals first one not being in range, 0.1336, and you effectively square it because the second one not in range either. That gives us 0.01784. Here we're told the heights of adult females are normally distributed with mean of 160, standard deviation of 8. So X follows a normal distribution, 160 mean, standard deviation of 8. Find the probably randomly selected adult female has a height greater than 170. So we want to find the probability greater than 170. Let's draw the bell curve. That's 160. We want greater than 170. 170 is there. And we want this shaded area here as our P. So usual, turn them to Z values. So 160 goes to 0. 170, don't know the probability because I can't use a table, so work it out with the formula. Oops. Z equals X minus mu over sigma. X is 170, take away the mean, divided by 8 this time, and that comes to 1.25. So our Z value here is 1.25. We can look that up in the table to find the probability. 1.25 looked in the table is 0.8944. You can see it's actually not that value because this is significantly less than half. So the probability of Z being greater than 1.25 is going to be 1 minus the probability which we looked up, which was Z being less than. So it's 1 minus 0.8944, and that equals 0.1056. We're now told a bit more information. Any adult female whose height is greater than 170 is defined as tall. An adult female is chosen at random. Given she is tall, find the probability that she has a height greater than 180. So we want the probability that her height X is greater than 180 given that she is tall, which means the height is greater than 170. If I draw that on my diagram, or as a diagram, there's a bell curve. The mean was 160. Given she's tall, so we know she's above 170, and we want 180. So the first thing we know is this area here, given she's tall, so her probability, this one has already been worked out in there. So she is in that area there. And we want to know what is the probability of that. We could say this is, if we use set notation, we could say it's A for that. So we're saying greater than 180 is our A. And then this bit here is B. Greater than 170 is B. If we looked at it like that, we could use conditional probability, and we could go and say that probability of A given B is the probability of A intersection B over the probability of B, which equals, what's the probability of A intersection B? Well, if you look at the diagram, you can see A intersection B. Where are they? Well, it is actually, A is on top of, A is inside, a subset of B, isn't it? All the values greater than 180 must all be greater than 170. So the probability of A intersection B is just the probability of A, and that's divided by the probability of B. So that is actually probability of A is being greater than 180 divided by the probability of being greater than 170. We've already worked out that we need the probability of A, we need a probability of x being greater than 180. So let's use our z values. The mean goes to 0. This is going to go to, you look up our, calculate it, so it's going to be z equals x minus mu over sigma, which is going to be, in this case, 180 minus 160, and sigma is 8, and that's going to give us 2.5. So that value is 2.5. If we look that up in a table somewhere, 2.5 in the table, 0.9938. Clearly it's not that, because that's the less than, so it's going to be 1 minus. So the probability of z being greater than 2.5 is going to equal 1 minus the value we looked up in the table, 0.9938, and that equals 1 minus that value, 0.0062. So that means for our conditional probability, we've got the probability of A over the probability of B. That's going to be a probability of A given B equals 0.0062 over. We looked it up in the, we worked it out in the previous one was 0.1056, and that equals 0.0587. Now in most cases you'd be quick just to understand that if you got a conditional probability here with a normal distribution, I didn't have to work my way formally through all this conditional formula and stuff. Since you know you want the probability of x being greater than 180, given that it's here, greater than 170, you can say I want this area as a fraction of that area as a probability of that. You just do the probability of this area divided by the probability of the whole area, and that will always apply. Right, this last part of the question, half of tall adult females have a height greater than h, find the value of h. Let's just remember that we're x is still following this normal distribution. The mean height is 160 and the standard deviation is 8. So draw our bell curve. (160). Now it says half of all tall adult females have a height of greater than h. So if they're tall, they go into 170, and half of this have a height greater than h. So that's h. Now I think we looked up, yeah, we want, we're considering that region to start with. We actually want only that bit. Now the whole of that region, if we worked out in the previous part A, it was 0.1056 for the whole of that, but we're saying half of them are greater than 8, so if we divide by 2, that will give us 0.0528, and that is our probability of that area in there. So we can change them to z values. This one becomes 0, I'm not interested in that, so the h, I've got a probability, I can just look up that probability. Except I can't look up that probability, I've got to look up 1 minus that probability, because that's not going to be in the table. So I'm going to look up 0.9472 is what I'm going to look up, and that will give me a value of h. This is as close as I get, 9474. A little bit lower, Well, the next one, 1.61, is quite a lot lower, so I'm actually going to just take this as the value, 1.62. So h is 1.62. Now if I use my z formula, I can find out what h is. So z equals x minus mu over sigma. So 1.62 equals, this time it's h minus, that's 160 over standard deviation of 8. Rearrange that to get h equals 1.62 times the 8, and then add the 160, and that's going to come to 172.96.